awesome little discussion over here. I'm going to pick on you guys because it was awesome right here. There was a chit-chatting about how to measure this better. I heard the statement, you know, just measure the percentage that falls within 5 points or whatever how many points. That's a fantastic statement. And I expressed concern that I have dealt with that very statement. I give lots of little extra credit opportunities as the course goes on. You're going to learn about a new one on Wednesday. You're going to learn about 2 new ones when you get your first 2 exams back. You're going to find the Stat of the Day blog is there. You're going to find all kinds of little extra point things hidden in assessments. I mean, they're all over the place. What I used to do was I would track students' exam performances. Exam 1, Exam 2, Exam 3. And I would say to myself, if they trend upward from Exam 1 to Exam 3, so if they went like 70, 80, 90, or 92, 85, 96, or something along those lines, and they were consistent, I would take 10% of the highest exam grade and add it into their overall average. The problem was the definition of consistency that I was using. None of these worked, and even the standard one that we're about to learn, one that's called standard deviation, doesn't work well over only 3 data sets, because I had to pick this range. Is it within 80%, within 10%, within 5%, within 20%? No range I picked was doing what I wanted it to do to indicate student performances. So that's the trick. That's the trick. So I would like to come upon one standard measure of variation. And I'm going to give you a hint on what it's technically called. This theme, or the theme of today's talk, and it's going to go into it's also going to go into Wednesday, is we just got done talking about measures of center. And I love that. But the problem is, center can fall flat on your face if 2 data sets are behaving the same centrally, but showing differences in other ways. And one of the ways they can show differences is this method of variation. So that's why I like pairing it up with measures. Or I'm going to put measure, or what the hell, measures of variation. And just like there are many, many, many ways to measure center, there's also many, many, many ways to measure variation. But the one I want to focus on is how to measure variation around an average. That's the one that statisticians use religiously, is they measure variation around an average. That's why I gave you the image of Bert and Ernie's heads with the blue line. Because I want you to use the blue line to talk about the variation. I want you to use that blue line. So how are we going to use that blue line? Everything you guys talk about up here is fantastic. All the methods of center, all the methods of variation and consistency, some of them are actually formally called things in the statistics world. Some are called things in the arithmetic world, percentages and ranges of values. Those are all great. But there's one particular measure. What do you think, Renee? What do you think?
Oh, well,
Go ahead, be brave.
There's 2 on each side.
Okay, 2 on each side. What you're doing is, you're saying, if you will, you're averaging around a median as opposed to an average. Good, she said there's 2 on each side. With Bert, there's 2 below and 3 above. With Ernie, there's 2.5 below and 2.5 above, if you will. And you can measure it that way. That's like a ranking system where you ignore completely the distances away. I don't want to do that yet because I think it's important. For example, I think a 61 is different than a 66. And I think a 68 is different than a 70, whatever that is. So I want to maintain the distances too. Thank you for that. We'll deal with that much more in 244, believe it or not. Please.
Grouping around, because it's an average of both their scores, so the grouping around the average would show more consistency for earning.
Good. When you say grouping, what are you doing with group?
Like all the other earnings are spread out.
Define spread.
Like from whatever the scoring of.
Use the average. I love this. Go with the average. So for example, here's a blue line, 81. What's this?
79.
79. So define it using that data point and the average. What's the difference? It's 2 away.
2, yeah.
It's 2 away. How about this data point and the average?
1.
It's 1 away. How about this data point and the average? It's on it. How about this data point and the average?
1.
How about that data point and the average? What are you thinking, Jared? What do you think? Go with it.
You still have to define how close to the average is good though.
Okay, but let's avoid good for now.
Yeah.
Because you hear what Jared said? You have to define how close to the average good is. I don't even want to worry about good or bad or a definition. Just if I look at pure numerical distance, I don't have to worry about that. Does everybody agree? These are two apart. I'm not calling that good or bad. I'm simply saying they're two apart. Is that fair? So I'm removing the definition from that. Is that okay?
Yeah.
Good. So, if we were to average those 5 numbers, what would you get? Well, you get 2, 1, 0, 1, and 2, which adds up to 6, which divided by 5 equals 1.2. That's called the average deviation. If you just simply add up the distances and divide by how many there are, it's called the average deviation. You can add that to your list. Unfortunately, nobody uses it. Unfortunately. And you'll learn why in 244 more. We can also do it with BERT. But what I'd rather do instead is an idea that's related to that. Because Stacy, you're that close. You're that close. I want to do an idea that's related to that is not intuitive at all. It's not intuitive. Nobody's ever, it's funny, whenever I ask people to come up with their own measures of consistency, I get so many freaking awesome answers, but nobody ever comes up with the one we're about to talk about, which is the standard measure of variation around an average. And you're about to see why nobody thinks of it, because it's very counterintuitive. But mathematically, it's brilliant. So let's swing over here. Let's start and stop.